Today we're moving on to dividing a line segment in a given ratio. Okay, so you have a formula first, and it's on page 18 of your formula and tables book. So it's for internal division. So it says in the given diagram, the point C defines the line segment PQ in the ratio A is to B. So here you have your line segment PQ, and then you have C, the internal division point. So to find that point here in the middle, okay, it is given by a formula, and the formula states that it's B times x1 plus A times x2 divided by B plus A, B times y1 plus A times y2 divided by B plus A. Now they will give you that A is to B, so they will give you the ratio. So whatever ratio is first, you label it A. Whatever ratio is second, you label it B. Your x1, y1 and your x2, y2 would be the end points of your line segment. So the first point of your line segment, which would be P here, you label it x1, y1. And the second point then, you label it x2, y2. Now note in your syllabus, it states the internal case only. However, that P and Q, so the extreme points, could be unknown, and you'd have to be able to find that. So I have two examples of just internal division of finding the C here, and then I have two examples doing the P and the Q, finding P and Q. The points could also be the extreme points. Okay, so we do example 1. So example 1 then states that A is 3 minus 1, B is minus 9, 1. Find the coordinates of the point C, which divides the line segment AB in the ratio 3:1. Okay, so first of all, I'll just make this really small so that you can see it. And then give myself more room. So the first thing we do is we draw our line segment. So our line segment was A and B. A was 3 minus 1. And B is minus 9, 1. Okay, so the first point of your line segment, you're going to label it x1, y1. And the second point, we label it x2, y2. Now, where is C? Now, it says C divides the line in the ratio 3:1. So if it's 3:1, then this line segment AB is divided into 4 parts. So 1, 2, 3, 4. Okay, and C then would have to be here because it's in the ratio 3:1. So this would be my 3 here, and this would be my 1. So the first ratio, you always label it A. The second ratio, you label it B. So for the formula then to work, which is B times x1 plus A times x2 all over B plus A. And to get the y value of the C, it's B times y1 plus A times y2 all over B plus A. Well, I have all my values. I have my x1, y1, the A, the B, and the x2, y2. So now I can just easily slash it into the formula. Okay, so then slashing it into the formula, then it's going to give me B times x1 first. So B times x1 is 1 times 3. So 1 times 3 plus A, which is 3, x2, which is 3 times minus 9, all over B plus A, which is 1 plus 3. So I'll just continue with the x value here for the C. So 1 by 3 is 3 minus 27 all over 1 plus 3, which is 4. So that will give me minus 24 all over 4. So the x value for the C is minus 6. Okay, looking for the y coordinate. So then again, we just slash it into the formula here. So it's B times y1. So it's 1 times 1 plus 3 times y2, which is 1 all over B plus A, which is 1 plus 3. So slashing that guy in then, so it'll give me B, which is 1 times 1, okay, plus A, which is 3 times 1, all over, that's a minus 1 there actually, that should be a minus 1, all over B plus A, which is 1 plus 3. So that will give me minus 1 plus 3 all over 4, which is 2 all over 4, which works out to be a half. So then that C coordinate is minus 6, a half. Okay, so just take a note there. If given fractions rather than ratios, you use the idea of translations. Now, translations could have been used in example 1 as well. Okay, we tend not to use translations when we're given a straightforward ratio. So I'll just go through this one here. So it says if A is 1, 11 and B is 5, 3, find the coordinates of C which divides the line segment AB if the length from A to C is 3/4 of AB. So we just draw it out graphically so you can see what we're talking about. Okay, so we have our line segment, we have A and B. Okay, so again it's 3/4, so our line segment has to be divided into 4 parts. That'd be my first, second, third and fourth. So C then would have to be here. Okay, because they told me it was divides AC is 3/4 of C. So then this section here would be 3/4. So then this guy here has to be 1/4. Now you could have done that in the ratio, like 3/4 to 1/4 would be the same as 3:1. But I just want to show you how we do it with translations. Okay, so the first thing you got to do is we're going to get the translation of the line segment. So we're going to get the full translation if A is mapped to B. So we're going to get A to B. So we'll get the translation, first of all, of A is to B. So A was 1, 11, okay, and B was 5, 3. So what is that translation? Well, we do our x's first. So if you went to 1 to 5, what would you do? You have to plus 1. And then to do your y's, if you go from 11 to 3, it's minus 8. Okay, so our translation then is 4 minus 8. Okay, so that is the full translation. Okay, but we don't want the full translation because C is only 3/4 of the way. So we're going to get 3/4 of that translation now. So 3/4 of 4 will give me 3. And 3/4 of minus 8 will give me minus 6. So that now is my translation. So we apply that then to A, okay? Because if we do the translation from A of 3 minus 6 to A, it's 3/4 of the line segment AB, and I'll get to C. Okay, so we go back to our A. So our A was 1, 11, and I applied 3/4 of my original one, which is 3 minus 6. So it's to get my x value, it is 1 plus 3. We just do 1 plus 3 here. Okay, so 1 plus 3 will give me 4. And then to my y's, it's going to be 11 minus 6. Okay, so 11 minus 6 will give me 5. So then my translation, or my C is 4, 5. So C now is 4, 5. So the first thing you've got to do is, if they give it in fractions, we can use translations. You get the full translation that applied to the line segment A is to B. You get the fraction of that translation of the translation. So in this case, it was 3/4, and then you apply it to your very first point. Okay guys, so we're going to do example 3 now. It says consider the points A, which is 4, 6, B, which is a minus 4, 2, and C is x, y. Given that the point B divides the line segment in AC internally in the ratio 2 is to 3, find the coordinates of C. Okay, so first of all, we're going to draw out to see what they give us. So they give us a line segment A and C. A, they said, was the point 4, 6, and C is the point xy. Okay, now B this time, they gave us the internal divisor. So they said B divides that. So B is along this line, but where it is, it divides it in the ratio 2 is to 3. So that means that line then can be divided up into 5 parts. Extend that there, and that's your 5 parts. Okay, so B then is in the ratio 2 is to 3. So 2 parts, so 1, 2. So B would be here. Okay, and that would give me the ratio. Okay, so that was the ratio 2 is to 3. Okay, so we'll start labeling then. So we know that when they give you the ratio 2 is to 3, the first ratio, which is 2, is my A. Okay, and my 3 would be my B. The first point of a line segment we label x1, y1, and the end point we label it x2, y2. So that would give me x1, y1, and x2, y2, and they gave me another bit of information. They told me what the internal divisor was. So the internal divisor is b, which is minus 4, 2. Okay, so we know that this formula here will give me the internal divisor. So in this question, we're looking for C, the end point, okay? But they told me what the internal divisor is. So if I had worked out this formula for AC, I would have got it equal to B. So we're going to put this formula then equal to what they said, so it's B. So B now is equal to the internal divisor formula. So all we got to do then is we're going to fill in as much as we know. Okay, so I'm going to move everything up so that I have room here, and I'll just move this up as well. So this is my XY, and then I'll just move this one up here. Okay, so we're going to fill in. So the first thing we're going to fill in is we're going to fill in for B, and B is minus 4, 2. So that will give me minus 4, 2 is equal to, and now I'm going to fill in the values into the X coordinate formula. So it's going to be B times X1 plus A times X2 all over B plus A. So slotting that guy in then, that would give me B, which is 3 times X1, which is 4. So that would give me 3 times 4 plus A, which is 2 times X all over B plus A, which is 3 plus 2. Doing the same then for the Y coordinate. So just filling in. So B is 3, Y1 is 6, plus A this time is 2, and Y2 is Y. So 2 times Y is equal to all over 3 plus 2. So all over B plus A, which is 3 plus 2. So now I'm going to work out this as much as I can, and then the Y coordinate as much as I can. So I'm still left with minus 4, 2. Oops. I'm still left with minus, get rid of that. So then I'm still left with minus 4, 2 is equal to 12 plus 2x all over 5, and 18 plus 2y all over 5. So I know that this first part represents the x coordinate and this represents the y coordinate. So you're going to equate the x with the b. So if I worked out the x's, I know I should get minus 4. And if I worked out the y's, it'll be equal to 2. So I'm going to equate now the x minus 4 with 12 plus 2x all over 5. So you equate the x's and then the y's. So that would give me, I'll just do it in black, that would give me minus 4 is equal to 12 plus 2x all over 5. So that would give me minus 20 is equal to 12 plus 2x. Bring over the 12, so that would give me minus 32 is equal to 2x. So my x value is minus 32 divided by 2 will give me minus 16. Okay, then I'm going to equate the y's. So put the y's equal to each other. So that would give me 2 is equal to 18 plus 2y all over 5. So 10 is equal to 18 plus 2y. 10 minus 18 is minus 8 is equal to 2y. So y is equal to minus 4. So I got my x coordinate to be minus 16 and my y coordinate to be minus 4. And we know that that is what we're looking for. So that represents C. So C now is minus 16 minus 4. Okay, so we do one more example. So then I said if A is minus 4, 2, and B is 4, 7, find the point C, X, Y outside of the line segment AB, given that AC is to BC is the ratio 3 is to 2. Okay, so we just draw out first of all what we have. Okay, so we have a line segment, they said it was AB, but they said the ratio A is to C, so that is A is to C is 3, and the ratio B, so B would be here, B is to C, which is 2. Okay, so if the whole line, the ratio is 3. So A is to C is 3. And B to C is 2. Well, the whole line must add up to 3. So if BC is 2, then AB must be the ratio 1. Okay, so we just draw that out then to what we're used to for the... So what do we have now here, we'll say? So we have A, okay, so A is the point minus 1, 2. B is the point here, okay, so B is here, so B is my 4, 7. And my C is the point here, and we know it's in the ratio 1 is to 2. Okay, so C, they said, is XY. So for this formula then to work, okay, we have to have the internal, just move this up a bit. So for this formula to work, okay, we have to use the internal divisor point, okay? So our internal divisor point is B, okay? So then this formula again, just like the last example, would be equal to the point B. So B is equal to that point. So in order to fill in then, we have to know what is A, B, and X1, Y1. Well, my A is my X1, my point A is my X1, Y1. My first ratio is A, my second ratio is B, and my C is going to be my X2, Y2. Okay, and then B is what I'm going to slash in here. So slashing it in then to the formula, we have B would be our 4, 7 is equal to, so B is the ratio 2 times X1 is minus 1, plus A is 1 times X2 is X2 is X, all over B plus A, which is 2 plus 1. Going on for my Y coordinate and filling in. So it's B, Y1, so it's 2 times 2, plus A, which is 1, times Y2, which is Y, all over B plus A, which is 2 plus 1. Okay, so I'm just going to move everything up so that I have room here now. Okay, so again, we know that this, so we'll just work this out here so for a second before we equate things. So this would be 4, 7 is equal to minus 2 plus X all over 3. Okay, and then I have 2 times 2 is 4 plus Y all over 3. So we know again that this guy represents the X, this would be the Y, and then the 4, 7 would be my X, Y. So then we equate the X's and we equate the Y's. So that would be 4 is equal to minus 2 plus X all over 3. And 7 is equal to 4 plus Y all over 3. Again, cross multiplying here then. So that will give me 12 is equal to minus 2 plus X. So X works out to be 14. So we're looking for the point C. So 14 would be my X coordinate for point C. Equating the Y's then, you ended up with 7 is equal to 4 plus Y all over 3. So we'll cross multiply. So that would give me 21 is equal to 4 plus Y. So Y then is equal to 21 minus 4, which would be 17. And that represents the Y coordinate of the C point. So for questions for today and tonight then, I want you to go to Schoology and I'll have line worksheets on. And I need you to go down to the section where it says divisor of a line segment. So I just took this from Effective Maths book. I just think they do a little bit better for this section than your book. So I want to do questions 1, 2, 3, 4, 7, 8 and 9. And then just know for question 8, it will say 2 times BC, okay, is equal to AB. So just note that 2 times B, that then bring you over the 2, that would be BC, it'd be the same as half of AB. So you're going to get the ratio 2 is to 1. And then just so for question 9, then it says PQ is 2/5 of PR. So then if this section is PQ is 2/5 of it, then this guy here has to be 3/5. So you could do it by translations if you want, but you can also use the ratio of this 2/5 is to 3/5. You can use the ratio 2 is to 3.